Questions 21 to 25 of the 2003 Grade 8 Gauss Math Contest. The sum of four consecutive whole numbers is a multiple of 5. Which of the following statements about these four numbers is always true? Well, there's a few ways to approach this. The first is to call them n plus 1, n plus 2, and n plus 3, four consecutive numbers. But unfortunately, that becomes a bit more complicated than we need to make this question. What I would do is just start off with some actual numbers and add them and see if the sum is a multiple of 5, and if it is, we go and look at the answer choices. So I'm going to choose 1, 2, 3, and 4. Can't get any more simple than that. The first four consecutive whole numbers, and the sum is 10, which is indeed a multiple of 5. So now let's look at the answer choices based on these numbers. The sum of the numbers ends in a 5. Well, that is not true. So A is gone. The sum is a 10. That does not end in 5. The largest number ends in a 9. Well, our largest number is 4, and that doesn't end in a 9, so that's out. The smallest number is odd. Okay, that is true. None of the numbers are multiples of 5, and that is also true. One of the numbers ends in a 3, and indeed that is true. All right, so we got rid of A and we got rid of B. So let's do this again with another set of four consecutive numbers that, when you add them, gives you a multiple of 5. And the next one will be 6, 7, 8, and 9. These are consecutive, and if you add them, these four, you get 30, and 30 is a multiple of 5. Now let's revisit the remaining answer choices with these four numbers. The smallest number is odd. Well, the smallest number here is 6, and that's not odd. So this is X. Cross it out. None of the numbers are multiples of 5, and that is indeed true. And let's just look at the last one. One of the numbers ends in a 3, and none of these end in a 3, so that's gone. So there you go. By process of elimination, we found that D is always true. Everything else has been proved to be false. So 21 is D. Carmina has a total of $3.60 in nickels and dimes. If her dimes were nickels and her nickels were dimes, then she would have $5.40. How many nickels and dimes does Carmina have? So initially she has nickels and dimes, and the total amount is $3.60. And a nickel is 10 cents or $0.1, and a nickel is 0.05. So dime is 0.1 and nickel is 0.05. Then what they're saying is that her dimes are nickels and her nickels are dimes. So the number of nickels she had now become the number of dimes, and the number of dimes she has become the number of nickels. So that's what they're basically saying with that statement. And therefore, our equation becomes a little bit different. And they tell us that this new total is $5.40. And now you just have to solve for N and D. And then at the end, they want you to find how many nickels and dimes. So basically what they're saying is find N plus D. All right, two variables, two equations. We can most definitely solve this. In any way that you feel comfortable, I'll call this equation 1, and this is equation 2. So what if I did 2 times equation 1, subtract equation 2? That would give me 0.1n plus 0.2d minus 0.05d minus 0.1n. n. And this would give me 2 times 1, $7.20. I'm looking at the right side now. Minus $5.40, like that. So let's see, the 0.1s cancel for the ends. And then we're left with 0.2 minus 0.05, which is 0.15. And that looks like 720 minus 540 is 1.8. And don't forget the d there. So now d is going to be 1.8 divided by 0.15, and that makes d equal to 12. And then I guess we now just substitute this back into any one of these to find n. So we can do that. D is 12, so 0.05 n plus 0.1 times d, which is 12, is equal to 3.6. So we got 0.05 n plus 1.2 is equal to 3.6. And we've got 2.4 is equal to 0.05 n. And therefore, n is equal to 2.4 divided by 0.05. And therefore, n is equal to 48. So there you go. D is 12, n is 48. They want you to find d plus n. So therefore, d plus n is 12 plus 48, which is 60. So that's the total number of dimes and nickels. And therefore, number 22 is D. In her backyard garden, Gabriella has 12 tomato plants in a row. As she walks along the row, she notices that each plant in the row has one more tomato than the plant before. If she counts 186 tomatoes in total, how many tomatoes are there on the last plant in the row? So she's got 12 of these tomato plants. And when she walks along, she notices that each one has one more than the previous one. So if the first one had, say, n tomatoes, therefore the next one would have n plus 1 tomatoes, like that. And then the next one would have n plus 2, n plus 3, and so on. N plus 4, dot, 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 all the way to the last one, which would have n plus 11 in terms of the number of tomatoes. And they tell you that the total is 186. So you have to add all of these together. So if you're adding n plus 1 plus n plus 2 and so on all the way up till n plus 11, that basically becomes 12n, because there's going to be 12 n's. And then 1 plus 2 plus 3, dot, 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 all the way up to 11. So 12n, and this sum is 11 times 12 over 2, and that's 186. All right, so 12n, and this looks like 6 times 11, which is 66, is equal to 186. And therefore 12n is equal to 186 minus 66, which is 120. And therefore n is equal to 10. They want you to figure out how many tomatoes are there on the last plant in the row. The last plant has n plus 11 tomatoes. So n plus 11 is 10 plus 11, and that's 21. 21 tomatoes on that last plant, so 23, the answer is D. In diagram, ABCD is a square with area of 25 centimeters squared. If PQCD is a rhombus with an area of 20 centimeters squared, the area of the shaded region in centimeters squared is. So here's that diagram blown up a little bit. Now they tell you that the square has an area of 25, so that means the sides are 5. All right. Now notice that DC is common to both the square and the rhombus. So that means DC is 5 for the square and it's 5 for the rhombus. Now what is a rhombus? Just in case you don't remember, It's basically a shape where all four sides are the same, but it's not at right angles. So very similar to a square, it's slanted, I guess, exactly what they show here. So that means all 5 sides are the same, like that. So that's pretty good, right? Helps us out. Now we have to figure out the area of the shaded region, okay? Shouldn't be a problem. Let's break that shaded region up into a couple of different regions, actually. So I've drawn a line to make it a triangle and a rectangle like that. Okay, and then I think if I draw one more line from P down to the bottom, it should help us, and I think that should be it in terms of our lines. Now let's label this. A lot of this stuff we don't know, but we will be able to figure out pretty quickly. I'll call this H, I'll call this X, and I think that's it. That's all we need to figure out. So the area of the rhombus is 20. Now how do you figure out the area of the rhombus? Well, you just multiply the length times the height, like that. So that means 5 times H is equal to 20, and therefore H is equal to 4. So put that in there, 4 right there. Now what is X? X you can easily figure out from Pythagoras. X squared plus H squared is 5 squared. X squared plus 4 squared, therefore, is 5 squared. X squared is 25 minus 16. X squared is 9, and therefore X is 3. So X is equal to 3. All right? So now, if this is 3, then that means this is 3 right here. If this is 4 from there to there, that means this is 4. And since the whole A to D is 5, that means this little space right there is 1. So now we have everything we need to figure out the area of the shaded region. Area of the shaded region, AS. First we want to look at this rectangle. Length times width, 5 times 1. Add to that this triangle. 1/2 base, which is 3, times height, which is 4. So this gives us 5 plus 12 over 2, which is 5 plus 6, and that is 11. So the area of the shaded region is 11 centimeters squared, so 24, the answer is C. In the diagram, a positive integer is to be placed in each of the 9 boxes so that the products of the numbers in each row, column, and diagonal are equal. Some of the entries are already filled in. The number of possible values for n is. So here's that diagram blown up. And first we need to figure out what is that product. They're saying that the product of all the numbers in each row, column, diagonal are equal. But what is that famous product here that they refer to? Well, there's only one diagonal that has all 3 numbers, so let's use that to figure out our product, and that is of course just 6 times 12 times 24, and that number is 1728. Okay, so if you take the numbers in any row, column, or diagonal and multiply them, they have to equal 1728. All right, no problem. Let's label this A, any order, B, C, D, E. The order doesn't matter. I mean, you can label them any letters you want just as long as you understand the question. So now let's systematically work one at a time. First, I'll concentrate on these 3. N times A times 6. That has to equal 1728, right? Because every row, column, diagonal, when you multiply the numbers in them, they have to equal the same. And our product is 1728. So from that I get n times A is equal to 1728 divided by 6, which is 288. And therefore A will be 288 over n. So this is 288 divided by n. My goal is to get everything in terms of n, and then I can compare them. All right, so we took care of 1. And in a very similar way, let's look at that. N times C times 24 is equal to 1728. And therefore, n times C is equal to 1728 divided by 24, which is 72. And therefore, C is equal to 72 over n. So 72 over n, like that. All right, where do you want to go next? How about the B? NB and 12? Right here. NB and 12, this diagonal. So that means n times 12 times B is 1728. And therefore, n times B is 1728 divided by 12, which is 144. And therefore, B is equal to 144 over n. 144 over n. And I think we got, what, 2 more? All right, we can do this. 1728 is going to be equal to 24 times D times 144 over n. I'm basically doing this guy right here, this column. And if you do the math here, you'll get that D is equal to n over 2. So that's n over 2. And one more, E. So 6 times E times 144 over n is equal to 1728. And if you do the math, you'll get E is equal to 2n. So there you go. We got all the boxes filled. So I am going to list those. Let's see, we got n over 2. Let's list them from smallest to largest. N over 2, 2n, or 72 over n. Or maybe this isn't being listed in any kind of order, but that's okay. At this point, we just want to figure out the answer. 288 over n. These are our values, right? These are what we need to figure out. Okay, so here we go. Now, what is the criteria of the question? The criteria is all the numbers, all of these numbers have to be integers. And that's the only way we are allowed to fill that magic square or magic table. So we have to find values of n that make all of these integers. Okay, well, I think that shouldn't be too hard. If I choose any integer for n, n over 2 will be an integer only if n is even. 2n will be an integer regardless for any n. If n is an integer, 2n will be an integer. So we don't have to worry about that guy. But these guys here, it's a little bit trickier. The only way that this can be an integer is if n divides into 72. So 72 divided by n has to be an integer. And the only way that can happen is n is a factor of 72. And very similarly, these guys will become integers in the same way if n is a factor of 72. Because if you notice, this is just 72 times 2, and this is just 144 times 2. So I need to concentrate on the factors of 72. All right? So what are the factors of 72? Let's see, we got 1. Before I make a list, a lot of times it just helps to break it down to its prime factor. So it's be 2 times 2 times 2 times 3 times 3, I believe. So that's what, 8 times 9? Yeah, 72. Perfect. Okay, now let's list all the factors of 72. Don't forget 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. How many did I get there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? So 12. 12 is one of the answers. But before you choose that, let's not get too hasty here. Let's go back and see if all the criteria is filled. If n is one of these guys, then this will be an integer, this will be an integer, and this will be an integer. And it's already an integer. 2n will be an integer. So everything is going well. But we got one that is not so easy. The only way that can be an integer if n is even. So of these 12, we only can use the even numbers. So what are those? I'll circle them. These ones. And how many of them are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So a little bit tricky there. A lot of people would choose 12, but you can't choose 1, 3, and 9 because if you did, this would not become an integer. So 9 is the answer, and therefore, number 25, the answer is C.